So friends, last time we left our video tutorial somewhere at this place. I was at the first century. I was dealing with the odd day calculation of the first century, that is from first AD to 100 AD, that is the first 100 years. I calculated the number of leap years as 24 leap years, number of normal years as 76 normal years, and thereby the total number of odd days came out as 124 odd days. What does this 124 denote? These 124 denote the number of extra days that we obtained when we tried to group the number of days present in the first 100 years in groups of 7. The point is that we tried to divide all the number of days in the first century, that is the first 100 years, in groups of 7, and we got these much days as extra, 124 odd days. So obviously, now this value of this 124 is greater than 7. And obviously, if I already said to you that odd days are the number of days which we get as remainder when we divide the period by 7. So obviously, if we are dividing a certain number by 7, then what can be the remainder? That remainder can be either be 0 or 1 or 2 or 3 or 4, 5 and 6. It cannot be 7. Because if it is 7, then ultimately the remainder will be 0. So, when we divide a number by 7, we can get 7 probabilities, 0 to 6 as remainders. So the point is 124 are the number of extra days. So again we are going to group these 124 in groups of 7. So again I will divide it by 7. 7 is 7, 5, 54, 7 is 49, 5 is remaining. So 5 is the odd days. So the point here is that what I have calculated that in the first century, that is from first AD to 100 AD, that is in the first 100 years, if I want to arrange all the days of the first century or the first 100 years in groups of 7, then 5 days will be extra. That is, I will not be able to arrange 5 days in groups of 7. This is what it means. This means that of all the days of the first century, if I want to divide those days in groups of 7, 5 days will be left. This is what this whole thing means. That is, that in the first century, that is in the first 100 years, that is from 1 AD to 100 AD, number of odd days obtained are 5. This is my concept. This also means that if you encounter a question like this, the question is something like this: 1st of January, 1st of AD is Monday. We all know. If I ask to you that what will be 1st of January 101 AD, then what will be your answer? I have told you that I have 1st January, 1st AD as Monday. We all know this. And if someone asks us that what will be the day on date 1st of January 101 AD, then what will be our answer? You need to see here that the intervening period here is the first century, because if we have taken 1st January, then we are going to calculate by the third method of calculation number of days from 1st January 1st AD to 1st January 101 AD, and we will subtract 1 from it. So obviously this whole -1 is the first century, that is 100 years. So obviously what we are seeing that in the first century the number of odd days is 5. So obviously, if 1st January, 1st AD is Monday, then we are going to move Monday forward by 5 days. So Monday forward by 5 days will give us Tuesday, Wednesday, Thursday, Friday and Saturday. So 1st January 101 AD will be Saturday. This is a way to proceed these sort of questions. You just need to know that in the first century, that is in the first 100 years, the number of odd days obtained by us is 5. That's it. This thing will become more clear to you in the next thing. I have calculated the number of odd days for the first century. Now I am going to calculate the number of odd days for the second century. After that, I will calculate the number of odd days for the third century. And then finally 4th century. And by the end of the 4th century calculation, you will be totally clear with this concept. Have a look. 2nd century. From which date to which date? It is from 101 AD to 200 AD. How many years? 100 years. Now, I have to jot down the leap years in it. What are the leap years? 104, 108, 112, 116, 120, 196. I am not writing 200 because in this case 200 is not a leap year. I already told you all those century years. 200 is a century year, it consists of 2 zeros. All those century years which are divisible by 400 are leap years. 200 is not divisible by 400, so in this case 200 is not a leap year. So we are not going to count 200 in the list of leap years. So I have to calculate how much is this? 104 to 196, again the same method. Final term minus initial term upon common difference plus 1. What is the final term here? 196. What is the initial term here? 104. This is the final term, this is the initial term. Upon common difference. What is the common difference? 104, 108, 112, 116. 4 is the common difference. 120. So 4 plus 1. How much will this come out as? It will come out as 24. So the leap years in it are again 24. And normal years? In it are 100 minus 24, 76. You know, in each leap year, there are 2 odd days, so odd days will be 24 into 2, 48 odd days. And in this 76 years, for every year there is 1 odd day, for every 1 normal year, 76 normal years, so odd days will be 76. So total odd days again 124. 124 odd days. So again I will write it 124. That means again the same thing. From 101 AD to 200 AD, in these 100 years, when I tried to divide the number of days of these 100 years by 7, I found that 124 days were extra. This is what this whole step tells us. 124 odd days. Now again 124 is greater than 7. So again I will group these 124 into days of 7, because what is the thing? The whole calendar concepts, the day finding concept revolves around the one simple premise. That is that a particular day of a week repeats after every 7 days. So whatever we are going to obtain extra days, we are going to divide them by 7. So here what the extra days I got? 124. I am going to divide it by 7 and again I get the remainder as 5, as in the previous case. So remainder here is also 5. So in the 2nd century, the number of odd days are also 5 days. That means the number of odd days in the 1st century was 5. The number of odd days in the 2nd century is also 5. 5 odd days. I hope it's clear. If still it is not clear, then now it will be clear. Because now I am going to calculate the number of odd days for the 3rd century. Have a look. The odd days for the 3rd century will again come out as 5. Many of you have got it, would have got it now. If you have not, you can see it again. I am telling it in a bit detail to you so that you are able to understand it. If still you are not able to understand it, you can readily leave your comments and queries in the comment section and I will reply to them. 20180, 380, 100 years. What are the leap years? 204, 208, 212, 216, so on to 296. I am not writing 300 as leap year because 300 is a century year and 300 is not divisible by 400. So obviously 300 is not divisible by 400 and 300 is not a leap year. So what is the way of calculating this thing? Our own method. Final number, that is 296, minus initial number 204, divided by common difference. Common difference is 4 plus 1. What it will give us? It will give us again the same number 24. So the leap years again 24. Normal years, 100 minus 24, 76. What are the number of odd days in it? 48 odd days. What are the number of odd days in it? 76 odd days because normal. Total number of odd days? 124. 124 odd days will further give us 5 on division by 5. So, 5 odd days in 3rd century. Again 5 odd days. So we got in 1st century 5 odd days, in 2nd century 5 odd days, in 3rd century 5 odd days. Same method, I did it 3 times so that you are dead sure on this thing. Now I am going to do the calculation for the 4th century. Have a look. 4th century. I am going to jot down the leap years in it. 304, 308, 312, 316, so on to 400. Now 400 will be counted because this century year, that is 400, is divisible by 400 and therefore it is a leap year. Now we have to count the leap year. Many of you would be knowing by now what the leap year is. Number of final term minus initial term upon common difference 4 plus 1. This comes out as 96 by 4 plus 1, which is 25. 25 leap years. So in the 4th century, how many leap years I got? I got 25 leap years. And how many normal years I will get? Total number of years are 100. I will subtract 25 from it. So I will get 75 years. Now for every leap year there are 2 odd days. So for 25 leap years there will be 50 odd days. For every normal year I will have 1 odd day. For 75 normal year I will have 75 odd days. So total number of odd days are 125. Now I got 125 extra days. Again, the further step, I am going to divide this 125 by 7. What will I get? 6 remainder. That is, in this case, the number of odd days are 6. So, what we have got here? 1st century, odd days 5. 2nd century, odd days 5. 3rd century, odd days 5. 4th century, odd days 6. That means, in the 4th century, when we divided all the days of the 4th century by 7, we got 6 extra days, not 5. In the 1st century, I got 5 extra days. In the 2nd century, I got 5 extra days. 3rd century, 5 extra days. 4th century, 6 extra days. That means, for the 1st, 2nd and 3rd century, when I divided the total number of days, respectively of 1st, 2nd and 3rd by 7, I got 5 as extra number. But when I divided all the days of the 4th century by 7, I got 6 extra days. 6 extra days. So in the 4th century, the number of extra days are 6. So please jot it down. Now the most important thing. Why I am telling you this concept? I am plugging it up. I hope you all have written it. If not, you can revise the video and again write it. How many odd days? For first century, 5. For second, 5. Third, 5. Fourth, 6. Now, I told you for first century 5 odd days, for second 5, third 5, fourth 5. Now, this consists of 100 years. This of 100, this of 100, this of 100. Total years 400. So if someone asks you that what are the total number of odd days in the first 400 years? So for first 100 years, odd days are 5. For second 100 years, odd days are 5. For third 100 years, odd days are 5. And for fourth 100 years, odd days are 6. So for first 400 years, the odd days will be the addition of odd days, individual odd days. So it will be 5 plus 5 plus 5 plus 6, 15 plus 6, 21. 21 odd days. So for 400 years, number of odd days are 21. Please make a note. For the first 400 years, number of odd days are 21. Now again, I will have to divide this 21 in groups of 7. I will divide it and I will find that it is exactly divisible. So what does this tells us? This tells us that the number of extra days or the number of odd days in the first 400 years are 0. In the first 400 years are 0. What does this imply? This implies that if on 1st January, 1st AD, if it is Monday, then on 1st January 401 AD, it will again be Monday. Have a look. This is 1st January 1st AD. I told it as Monday. We know it is as Monday. And if we have to calculate 1st January 401 AD, then what is this time? This time, the intervening time is 400 years. And we see that in the first 400 years, the number of odd days are 21. And when I divided 21, I got the remainder as 0. So the odd days are effectively 0. So if the odd days are effectively 0, the day is going to repeat itself. Because we have to make no compensation because the remainder is 0. So if 1st January, 1st AD is Monday, then 1st January 401 AD will be again Monday. Because after every 400 years, the number of odd days are 0. And if the number of odd days are 0, then the day is going to repeat itself. This is as simple as that. This holds for every century. Now I will tell you the cumulative effects of various centuries. For first century it is 5. For first 2 centuries it is 10 odd days. For first 3 centuries it is 15 odd days. And for first 4 centuries it is 21 odd days. You need to understand this. This effectively tells us that at the end of the first century, what is the number of odd days? 5. I told you that 1st January 1st AD, if it is Monday, then on what will be the day on 1st January 101 AD? It will be Saturday. That will be 5 days after Monday because the number of odd days are 5. But the question here becomes something like this. What we got? We got something like this. 1st January 101 AD, we calculated as Saturday. Now if someone asks us that what is 1st January 201 AD, then what will be our reply? 1st January 101 AD, 1st January 201 AD. What is the intervening period? The intervening period is the 100 years. That is the 2nd century. And how many odd days are there in the 2nd century? 5 odd days. So what we are going to do? We are going to increase this Saturday by 5. We are going to increase this Saturday by 5. So what will we get? Sunday, Monday, Tuesday, Wednesday, Thursday. So 1st January 201 AD will be Thursday. Again I am telling you. I told you 1st January 1 AD is Monday. First century consists of 5 odd days. So exactly 1 century afterwards, that is on 1st January 101 AD, what will be the day? It will be 5 days ahead because 1st century consists of 5 odd days. So it will be 5 days after Monday. That is Saturday. Now I know that 1st January 101 AD is Saturday. Now I want to calculate the day on the first date of which? 3rd century. That is 1st January 201 AD. So on 1st January 201 AD, if you have to calculate, then we have to move 5 ahead of Saturday, because the number of odd days in the 2nd century is 5. So 5 days after Saturday comes out as Thursday. Now look at the cumulative effect of this thing, please. 1st century and 2nd century cumulatively has 10 odd days. So if it is given to you that 1st January, and it is already known to us, 1st January, 1st AD is Monday. And if someone directly asks us that what will be 1st January 201 AD? 1st AD, 201 AD. What is the intervening period? The intervening period is 200 years. 200 years means first 2 centuries. First 2 centuries means this period and this period. So for this period and this period, what are the total number of odd days? 5 plus 5. 5 plus 5 comes out as 10. And when we divide 10 by 7, what will we get? We will get 3. That means we have to move this Monday forward by 3. So if we will move this Monday forward by 3, what we will get? Tuesday, Wednesday, Thursday. So it will be Thursday. It doesn't matter through which method you are proceeding. The answer is going to become same. In this method, the answer was same. In this method, the answer is again same. I will tell you again this thing. 1st century, 1st January, 1st AD, Monday. What is 1st January 101 AD? Intervening period, 100 years. After every 100 years, 5 odd days in the 1st century. So 1st January 101 AD will be Saturday. 5 days after Monday. Similarly, 1st January 101 AD, Saturday. What is 1st January 201 AD? It is again 100 years afterwards. 2nd century. 2nd century, odd days, 5. So if 2nd century odd days 5, we have to move 5 days ahead of Saturday. When we will move 5 days ahead of Saturday, we will reach Thursday. Simple. Now, we have to do it directly also. Why it is need to go 5-5? If we take the cumulative effect of first 2 centuries, what are first 2 centuries? 200 years. For 1st century odd days is 5. For 2nd century odd days is 5. So total number of odd days are 10. When we divide 10 by 7, what will we get as remainder? 3. So the effective number of odd days are 3. So if 1st century 1st AD is Monday, and we have to calculate 1st century 201 AD. So what is the intervening period? The intervening period is 200 years. That is the first 2 centuries. And what is the cumulative effect of that 200 years? 10 odd days, which ultimately buckles down to 3 odd days. So what we have to do? We have to increase this Monday by 3. That is 3 days afterward, which will come out as Thursday.